Hey everybody, so you guys should have already checked in to class, and hopefully you're having a fabulous Tuesday. I'm so sorry that I wasn't able to greet you today and play a song, but that's okay. Now you get to hear my loud and obnoxious voice right now. All right, so the first thing that I want to do with you guys is you're going to hold on to this page. Your assignment was page 23, or you had to read page 22 and then do 1 through 5 on page 23. You're going to hold on to this and you're going to show me this on Thursday. Thursday. All right, but I'm going to go through these really quick with you. So what we found out, because we actually already did this problem, remember? So this was the problem. Let me pull this back up again. All right, remember? So this was the pool problem. So remember what we did? All right, there were several groups that got the right answer to this. So you guys had to you got the scale factor, you multiplied each of these by your scale factor to get the actual dimensions. Then you took your actual dimensions with the new scale factor and you divided it because you were getting a new drawing, and this was your answer. So therefore, number 1, the new dimensions were 6 centimeters by 3 centimeters. Now, number 2 says, look at model it. Look at model it. So here's the model it. All right. Now, if you look at the model it, look what they did. They actually, this one right here, for half of a centimeter was 3 meters. 1 centimeter was 6. 1.5 was 9. Okay. So this was pretty much converting the drawing to the actual length and width of the pool. And this one, okay, 1 centimeter to 5 meters was the scale that we used to change the actual pool to the new drawing. So that's what this is. How are those number lines related? Well, 1 changed the scale drawing, the scale, oops, sorry, this should say drawing, to the actual dimensions of the pool, right? And the other one changed the actual pool to a new scale drawing. So basically, it helped us just do some conversions. Now, number 3, look at the now and analyze it. So analyze it was this. Now, we did not talk about this in class, so let's take a look. How do the dimensions of the pool in the original drawing compare to those in the new drawing? Well, the dimensions of the original drawing, so this was our original drawing right here, and they were by 5 by 2.5. Okay, to the new scale was 3 by 6. Okay, so I want you to look at this. Okay, to go from here to this one is 5, 6, right? Or yeah, it's 5 to 6, or I'm sorry, 6 to 5, right? And this one went from 3 to 2.5, right? Hey, well, I want to show you a little secret. 6 divided by 5 is 1 2/10. 3 divided by 2 5/10 is 1 2/10, right? Well, look at this. If you look at the scale factor was 6 to 1. That was my first scale factor. Then my second one was 5 to 1. So look at this right here. So basically the comparison from this one to this one was 6 to 5, right? Well, watch. 6 divided by 5, oh my goodness, is 1.2. Okay, so that actually is another method that you guys could do, is you guys could actually just take the original dimensions and multiply it by this to get these new dimensions. Okay, but we can talk about that later. Now, the new drawing is a scale drawing of both the actual pool and the original pool. Why? All right, because the reason why all of these shapes are the same. Okay, because watch. Okay, the original was 5 by 2.5. Okay, then we converted it to, oh, don't mind, you guys don't mind, these are not in correct order. Okay, so just bear with me. The next one was 15 by 30, and the last one we had was a 6 by 3. So all of these right here are equivalent things. If I were to go length by width, 5 to 2.5, that's half, or 2. 30 divided by 15 is 2, and 6 divided by 3 is 2. So these are all the same shape. Okay, now this one right here, there's a lot of different options that you guys could have had, so I'm not going to grade that. Okay, but again, so what we're doing today is we are going to continue into the world of changing or redrawing scale drawings to other new scale drawings. Okay, so with that being said, I want to take a look at one that I just did. Okay, so the actual perimeter of the same shape as this is 112 meters. Each square on the scale drawing is 1 centimeter. Okay, all right. So if I know each one of these is 1 centimeter, let's go through and label all the sides. So this is 2, 2, 2, 2, 2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. All right. So those are the dimensions on the drawing. Now, what we know is we know that the perimeter of the actual shape that's like this is 112 meters, right? Well, they don't give us the scale factor of this, do they? So the only thing that we can go off of is the perimeter of the actual to the perimeter of the drawing. That's the only two pieces of information that we can go off of in order to make a new scale drawing. So let's find, we know that the actual perimeter is 112. And let's add up all these sides to find out the perimeter of this shape. So 6 plus 6 plus 6 is 18, 20, 22, 24, 26, 28. So the perimeter of the drawing is 28. If I divide these, this comes out to be, well, let's see, shall we? So if we're going to divide these to find it, 112 divided by 28 comes out to be 4. So our scale factor is 4, right? So to find out each actual length of these sides, I'm going to multiply these by 4. So 6 times 4 is 24. So this side's actually 24 meters. This is 24 meters. This is 24 meters. Okay, and then 6 times 2 is 12. So this is 12 meters, 12 meters, 12 meters, 12 meters, 12 meters. Okay. Okay. So now what I know is I know the actual lengths of each of these sides. Okay. So if I were to go build this, whatever shape this is, whatever building it is, I would know that this side, which is 6 centimeters on here, in real life is 24 meters. But now let's look. We want to make another scale drawing of this using the scale of 10 meters to 1 centimeter. What would the new drawing look like? All right. So now what we're going to do is we're going to do another scale drawing of this. Okay. We know our scale is right here. I'm going to do this right here to separate it. Okay. So my scale is 10 to 1, which is 10, right? So I'm going to take the actual side, 24, and I'm going to divide it by 10 and know that my new scale drawing is going to have a side length that is supposed to be on this side of 2 4/10. Okay, and then 2 divided by 10 comes out to be 2/10. So if I had to draw that, look at what it would look like, and I'm going to guesstimate. So 1, 2, and 4/10 is probably about right there. Okay, 2/10 over is probably about, yeah, there, right there. Okay, 2/10 down is right about here. Oh, back to here, sorry. Is it back to there? Yep. And then, okay, so wait, that's 4/10. Oh, it's probably right up here. And then 2/10 over, oh geez, I'm sorry, you guys. I'm going to start over. All right, so 2 4/10. 1, 2, 4/10 is probably here. It's not quite over halfway. Then if I go 2/10 over, so that's 2/10. Then I'm going to go down 2/10, over 2/10, up 2/10. All right. All right. And then down 2 4/10. Looks kind of funny, I know. But if I were to draw that out, that's about how it would look. Okay. All right. And obviously that's probably not the best picture of you guys to look at. All right. But these would be your new dimensions if you had 10 meters to 1 centimeter. So again, what we did is for this problem, the only information that they gave us originally is that the perimeter was 112 meters. Okay, so we found the perimeter of the drawing by adding up all the sides, and we got 28. 112 divided by 28 comes out to be 4. So our scale factor is 4. To find the actual, we took each side and multiplied it by 4. And that's where Mrs. Parkin made her mistake. I was wondering why this was so funny looking. Look at what I did right here, you guys. Oh no, I guess I'm okay. I'm okay. Nope, I'm not okay. This should have been 4 times 2. So these sides right up here should have been 8. So this should have been 8 divided by 10, which is 8/10. All right, now this is going to make way more sense because this was super skinny. All right, so if I go 2 4/10, right, then if I go down 8/10 right about here, over 8/10 right about here, up, that looks way better, way better. Okay, all right, so now I want to take you guys and I want to look at a couple more problems. Okay, so look at this. The drawing at the right is a plan for an apartment. The length of each square on the grid represents 1 centimeter. The scale from the apartment to the drawing is 8 feet to 1 centimeter. So the actual will be 8 feet to the drawing, which is 1 centimeter. So our scale factor is 8. So if you look at this, right, okay, we know that this side on my drawing is 3. This is 4, 1, 2, 3, 4, 5, 2, 2, and 2. Okay, so those are all my dimensions. If I wanted to know the actual dimensions, I'm going to take each side length and multiply it by the scale factor. So 4 times 8 is 32. So that would be, so this side right here would actually be 32 feet in real life. 5 times 8 is 40 feet. So this is actually 40 feet. This time 2 times 8 is 16. So this is really 16 feet. That's really 16 feet. That's really 16 feet. Okay. And then this one right here is 3 times 8, which is 24 feet. So this is actually 24 feet. Okay. So now what I did is I found the actual dimensions of this shape. Okay, so what I did again is I used my scale factor, which they told me right there. Now, we are going to draw another scale drawing of this apartment, but now we're going to use a scale of 4 actual feet to 1 centimeter. Okay, so 4 actual feet to 1 centimeter. Well, right now, so actual to drawing would be 4 to 1, which is 4. So our new scale factor is 4. Well, we know the actual measurement of this is 32. So to get the new drawing, we're going to divide it by the scale factor. So that becomes 8 centimeters. So this side right here is going to turn into 8. We're going to go 40 divided by 4. So this side is going to be now 10 centimeters on my new drawing. Okay. Then we're going to go 16 divided by 4. So this side's going to be 4 centimeters in length, which this one and this one will be the same. Okay. All right. And then 24 divided by 4 comes out to be 6. So if I were to draw my new scale drawing, okay, I'm going to start down here, and it's now 8 centimeters. So 1, 2, 3, 4, 5, 6, 7, 8. This is up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it's over 1, 2, 3, 4. Down 1, 2, 3, 4. Over 1, 2, 3, 4. And then down. Okay, so this is what the new scale drawing will look like after we did all of those conversions. Okay. All right, let's take a look at number 7. The image at the right is a 4-square court from a scale plan of a park. The scale from the actual court to the drawing is 8 feet to 1 centimeter. Okay, so what we know is when we convert this to find our actual 4-square thing, we're going to use our scale factor of 8. All right, so let's go ahead and find the actual measurement. So we're going to go 3 times 8, which is 24. 24 feet. So what that means is that this is actually 24 feet and this is actually 24 feet. Okay. Now, we're going to make another scale drawing of the court from the actual court, from this actual court, to a new scale drawing with that as our scale. So our new scale is 12 to 1, which is 12. So that's our new scale factor. So since we're going from the actual down to a new drawing, we are going to divide. And that comes out to be 2. So if I were to make a new scale drawing of this, okay, it would be 2 centimeters by 2 centimeters. So I found out what my actual length and width were. Then using my actual length, I used my new scale factor and divided it by that scale factor to get my new drawing. Okay, all right, last example. A design for a playground includes a sandbox. The length of a square on the grid represents 1 inch. So each one of these is 1 inch. The scale from the playground to the drawing is 12 inches to 1 inch. So what we know is our scale factor is 12 inches to 1 inch. Okay, so let's take a little peek at this. If this side is 1, 2, 3, 4, 5, right, 5 inches, and this is a square, all sides are 5 inches. So to find out what the actual side would be, we're going to take what the measurement is on the drawing and multiply it by the scale factor, and it comes out to be, in real life, 60 inches. So the actual is 60 inches. Now it says we're going to draw another scale drawing of a sandbox using the scale 20 inches to 1 inch. So we're going to use a new scale drawing with a scale factor of 20 over 1, which is 20. Now, we know if this side is 60 and our new scale drawing is 20 to 1, we're going to take that side and we're going to divide it by 20. And so we find out that the new length is going to be 3 inches. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, so there it is. There's my new scale drawing of this sandbox. Okay, now I know I went through this really quickly. Since I did go through it really quickly, you might actually have to watch this a couple times or pause and write down the work and then play. Pause and play, pause and play. And that's fine. You can totally do that. Here's what I want you to try to do today. So for your homework, what I would like you to do is I would like you to try, sorry, I'm going to look for the best possible one. I want you to try to do number 2. So on page 25, you guys are doing number 2. Okay. All right. Now this has fractions in it. Okay. So use a calculator or go back to how we learned how to multiply fractions. You're going to do number 4, which is just basically what we have been doing. All right. And then you're going to do number 5. And on number 5, this is the one where they tell us the perimeter of this. So the very first step, in order to find the scale factor, we know the perimeter of the actual one is 150 meters to the perimeter of this one, which is the drawing, the perimeter of the actual to the perimeter of the drawing, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 5 is 20, 10 more is 30. All right, so if we know that, if we divide those, There's my scale factor. Okay. All right. Okay. And then you're going to have to use that scale factor to find what the actual dimensions of this pool would be. And then take that and make it a new scale, draw a new scale drawing. Okay. And that's just like what we took a look at. So try these the very, very best that you can. All right. And that is what your homework assignment is for tomorrow.